Okay, so just like we did on Friday, we're using the same rules. Power rule we use almost all the time. Product rule we use sometimes. Quotient rule we use sometimes. Chain rule we use sometimes whenever those are needed, right? Those are the rules that we use. The only added little caveat, the only added thing is that anytime we find derivative of y, we have to give it a tag, right? dy over dx. Because we're used to solving things, we're used to finding derivative of things x, right? Well, now we're still doing that, but we also have y things, okay? Okay, so number 5. What do we do first? What do we always do first before we even start with finding derivatives? Square root, right? Square root. That doesn't change, even though it's their non-functions. We don't change what we do. Okay. So now you're going to find derivative of both sides. Well, let's start with the left side. The left side of the equal sign. What are we going to use? What rule are we going to use to find the derivative of this guy? Chain rule. So chain rule says the derivative of the outside first. So something to the 1/2 power, right? So we move the 1/2 to the middle. Inside stays the same. Subtract the whole power, which means negative 1/2. Chain. And then we find the derivative of the inside. The derivative of the inside is just two terms. It's x and positive 2y. So because it's a binomial, I'm going to put them in parentheses, okay? Because it's this times the whole binomial. If I didn't put parentheses, it would just be this times the first term, okay? So the derivative of x is just 1. The derivative of 2y is 2 dy over dx. If I didn't have those parentheses, it would just be times 1, right? But it's not times 1. It's this guy times this guy, okay? Without the parentheses, it's just this times this, and that's not what I want. I want times the whole thing. So that's why I put parentheses around this guy, okay? And then the derivative of 5y is just 5 dy over dx. Okay? Derivative is done, but anytime we have dy dx's, I have to isolate them. That was done for you last chapter. This time, it's not done for you. Okay? So there's a dy dx here. There's a dy dx here. Okay? So I can divide by this guy here. But it wouldn't do anything to isolate the dy dx's. So I have to isolate the dy dx's. To do that, I'm going to do something that we did on Friday, the last problem. I think it was the last problem we did. We have to distribute. Distribute. Okay? So it's going to be, so what are we distributing? We're distributing this entire term times positive 1 first. When we do that, it's just going to repeat itself, right? Anything times 1 stays the same. So we're going to have 1/2 x plus 2y to the negative 1/2 plus, and then we're going to multiply this term times this guy now. When we do that, you're going to multiply the 1/2 times the 2, which is going to make a 1. So there's not going to be anything. There will just be a 1 out here, right here, for this guy. Okay? Okay. So we have x plus 2y negative 1/2 dy over dx equals 5 dy over dx. Okay? So now I have 3 terms. 2 on the left side of the equal sign, these two guys, and 1 on the other side of the equal sign. Well, these two guys here have dy dx's, so I need them on the same side. I need them on the same side. So the easiest way, I think, is just to subtract all of this, subtract it from both sides. It's not the only way, but I think it's the step that takes the least amount of steps required. dy over dx. Okay. So that becomes 0. So I have 1/2 x plus 2y to the negative 1/2 power equals, and then over here now, I have 5 dy over dx minus this guy. Okay. Now the dy dx's are on the same side, so I'm going to factor that out like I've always done. So I get 5 minus the other side stays the same. Divide by what I don't want on this side. I don't want all of this. And 1/2. Okay. For this chapter, I'm not concerned about. Last chapter, I said anything with a negative exponent, make sure you make it positive. This chapter, I'm not really that concerned with it because, I mean, it's just going to give you more of a headache to have to do that, because when you're dealing with it, this is a lot of like algebra type stuff. So I'm not going to be that much of a stickler for this chapter for negative exponents. Leave them. Okay, unless it specifically says in the question, no negative exponents. But for this chapter, you're not going to really see that. So the 2 here, the only thing I would do is the 2, move down to the bottom, and then it's going to be 2 like that. Okay. So you would get x plus 2y to the negative 1/2, and then 2, 5 minus x plus 2y to the negative 1/2. That's as far as I'm good there. Okay. You can distribute the 2 to the bottom, but you don't have to. Okay. All right. So anytime you have to do distributive property like we did at the top, these are considered the more difficult ones, right? Easy, medium, difficult. These are the difficult ones. Example 5 and then example 4 that we did, the last one we did on Friday. Those are the difficult ones. Will there be one like this? Yeah, if you're taking a test, you'll probably have one question like this. The rest of them are going to be easy and medium questions, okay? All right. Okay, let's look at number 6 now. Number 6, we kind of change things up. There's no dy dx's anywhere. We still have an equation, negative xy squared plus 5x equals 1. But what we have to do now is find the equations of all tangent lines. The equation of all tangent lines. Okay? So equation of a tangent line, you guys just did this last chapter. Y minus y1 equals slope x minus x1. Right? We have to fill out that guy, those green guys. Well, we already know one of them, x equals 1, right? So we got to figure out the y, and we got to figure out the slope. So to find a slope for the equation of the tangent line, what do we need? What's the thing we need? We absolutely need derivative, right? We need a derivative. If we're going to find a slope of the tangent line, we absolutely need a derivative. So we got to find the derivative of this guy, first thing. Okay. Let's see. So this guy's got one term here, and then on the other side of the equal sign, it's got 3 terms. So it's got 3 terms that I have to do. So for the pink, what am I going to use for the pink to find the derivative of the pink magenta color? What? Product rule, right? I have to use product rule. It's negative 1x times y. Negative 1x times y. Okay. So the derivative, product rule says the first, negative 1x, times the derivative of the second. 2y dy over dx. Now, the second times the derivative of the first, negative 1. Okay, that's the derivative of the pink. The derivative of the light blue, 5x, is just 5. And then what's the derivative of 1? 0. There's the derivative. Okay. So now I have to isolate dy dx. I have to isolate this guy. Everything else has to be on the other side. Okay, so anything with a dy dx, without a dy dx, I'm going to subtract or add or whatever. So I'm going to subtract 5 from both sides. These two guys, if I multiply them together, it's negative 1y squared, right? So to add it, I would be adding 1y squared. Or just y squared. Okay, these guys go away. These guys go away. So I get negative x. So I'm going to rewrite this. Instead of negative 1x times 2y, I'm going to say negative 2xy. That's really what it is. And then negative 5 plus y squared. Divide by what I don't need. What I don't want to stay. dy over dx equals negative 5 plus y squared. That's my derivative. Okay? So to fill out the equation of the tangent line, I know x is 1, so I got one of those guys. How do I get the derivative, or how do I get the slope? What am I going to do to get the slope? Plug in what, where? You're right, I'm going to plug in something, but what am I going to plug in? 1. I'm going to plug in 1 where? Into the derivative, right? So this is the derivative here. If I plug in 1, what am I plugging it in for? X. But look at, there's also y's. So in order to plug it in and get a number, which needs to go here, I got to find y first. So how do I figure out what y is? So I got to figure out what is y first before I plug in. You guys are right, I'm going to plug into the derivative. But this one has x's and y's. So I can't just plug in x. I have to find out what the original y was. So how do I figure out what the original y was?
Plug it in, plug x into the original.
Plug in x to the original. Plug in 1 to the original. Okay, I got to do that first before I can find my slope. Okay, so here we go. So the original, was negative x y squared plus 5x equals 1. And I'm plugging in 1 for x. Since x was 1, okay? So that's negative y squared plus 5 equals 1. Subtract 5 from both sides. Negative y squared equals negative 4. Divide by negative 1. I get y squared equals 4. If y squared equals 4, what does y equal? 2. Is that the only thing that multiplies together to make 4? Negative 2, yeah. Positive 2 times positive 2, plus or minus 2, right? And negative 2 times negative 2. So there's actually 2 points here. It's not just one. The first point is 1 comma 2. The second point is 1 negative 2 because it's not a function, right? It's not a function, so it might have 2 points, 2 tangent lines. Okay, so now that I have that, now I can go back to my derivative and get the slope. So dy over dx, I'll do 1, 2 first. So I'm plugging in 1 comma 2 first. So I plug in 2 for y, and I plug in 1 for x. Oops. And 2 for y. So on top I get negative 5 plus 4, which is negative 1. On bottom I get negative 4. So I get positive 4. So when x is 1 and y is 2, the slope is positive 1/4. There's one of my answers. Okay. The other answer is going to be similar, except it's going to be y plus 2. Okay. Okay, so now I'm going to plug in dy over dx 1 comma negative 2. So y is negative 2. X is 1, y is negative 2. So negative 5 plus 4 is still negative 1. Negative 2 times 1 times negative 2 is positive 4. So their slopes are just opposites of each other. Okay. All right. So we have 2 equations of a tangent line. That'll happen sometimes when you're dealing with non-functions. Functions are only going to have 1. Non-functions might have more than 1. Okay. All right, let's flip it over. So take a look at the question. Without doing anything, tell me what I'm going to do. Read the question. Tell me in words what I'm going to do. What I'm going to do.
Find the derivative.
Find the derivative, good. And then?
Of the equation, like at the point x to y minus 1.
Exactly. I'm going to find the derivative, and then what am I going to do with the point? Plug it in, right? Find derivative, plug in the point. They give me, luckily they give me an x and a y, so I don't need to find the y like I did the last one. They tell me. So really, what is that? If I find the derivative and plug in a point, what am I finding? What is that called? Slope. Slope of the tangent line. Yeah, so this is really just saying, find the slope of the tangent line at 2, -1. Okay, so let's find the derivative. So the derivative of y cubed is 3y squared dy over dx. The derivative of 2x is just positive 2. The derivative of x squared is 2x. The derivative of -2 is 0. And the derivative of y squared is 2y dy dx. So here's the thing. You can isolate dy dx and then plug in the point. But when we plug in points, when I have an x and a y, you can do it before. So I can plug in x and y right now and then isolate afterwards. Or you can isolate now and plug in afterwards. It doesn't matter. It doesn't matter. Usually I like to do isolate last because to me, isolating dy dx is kind of the least fun thing to do. You know, it's just, I don't, that's the part about implicit that I just really, I don't hate it, but it's just like annoying, right? It's getting dy dx by itself, right? That's what makes your answers kind of ugly. So those things, I put it to the end. Do you have to, can I isolate dy dx right now? Yes. You can do that and then plug in the point. But usually when they give me a point, I plug it in first and then isolate. Watch, because it's going to be a lot easier to do it this way. So I'm going to plug in everywhere I see a y, I'm going to plug in -1. Everywhere I see an x, I'm going to plug in 2. Okay, so 2 is x, so that goes here. -1 is y, that goes there and there. Okay, simplify. -1 squared is 1, times 3 is 3. So this becomes 3 dy dx plus 2 equals, 2 times 2 is 4. 2 times -1 is -2. Now I want to isolate the dy and dx's. Okay, so anything with a dy dx, I want to move on one side. Anything without a dy dx, I want to move on the other side. So let's see here. I got 3 dy dx and I got -2 dy dx. So you can add 2 to both sides. Or you can subtract 3 from both sides. It doesn't matter. Your slopes will be opposites of each other. Opposite, remember we talked about, if it's opposite, actually no, I think your slope will be the same. Let's see. So I'm going to add 2 to both sides because that's negative and I want positive numbers. I prefer positive, so that's why I added 2. And then subtract this 2 from both sides. There we go. So you can actually add these. Well, these guys go away, and this guy is 2. These are like terms. 3 dy dx, 2 dy dx, they're like terms. So how many dy dx's do you have? 5. Divide by 5. So the derivative of the slope of the tangent line at the point was 2 -1 is 2/5. To me, that's a little easier than isolating first and then plugging in. But like I said, it doesn't matter. When you get a point, you have options. 1 through 6, they didn't give us a point. So we didn't have an option. I had to isolate dy dx first and then do that. And then, in the last one I could plug in. They didn't give me a point though. So the last one they gave me an x, I had to find y. But if they give you a point, you have that option. Okay. Okay, let's see here. Oh, good. Vertical tangent lines. Yep. Number 8 and number 9, I took from a past FRQ. A past FRQ. So implicit differentiation, what we're doing in this lesson, shows up both in multiple choice and free response. Kind of like the chain rule shows up in both. This one is big. This one's a big topic. Usually on a AP test of like 40 multiple choice questions, you'll get a good number of them that are implicit. And maybe 1 or 2 FRQs. It's one of the big topics in this chapter. Probably the biggest, that's why we start with it. Okay? So find the points. Points mean X and Y. They want me to find X's and Y's, points, where this guy has a vertical tangent line. So before we even do anything, before we even start the problem, set up a plan. I know it's points. I know my answers are going to be an x, comma, y. And I know how to find the derivative of that guy because we just did it. We've done 7 problems where we've done it. So, okay, I kind of understand that. But I haven't seen these 3 words together. What does vertical tangent line mean? I know what it looks like. Vertical tangent line.
No way.
But what's special about a vertical tangent line? What's undefined? You're right. What's undefined? The slope is undefined. Yeah, the slope of all vertical lines is undefined. Okay? So let's write that down. Okay, slope is undefined. Okay, so if we want to find anything with a tangent line, we have to find derivative first. Okay, so let's find the derivative. So the derivative of 4x squared is 8x. The derivative of y squared, 2y dy dx. The derivative of negative 8x, negative 8. The derivative of 4y, 4 dy dx. The derivative of positive 4 is 0, and the derivative of 0 is 0.
Even greater 0.
Yes, an even greater 0. Okay, so do we have any points to plug in?
No.
For x and y? No, we don't. So we can skip that step. So now we got to isolate dy over dx. Okay. So anything with a dy dx either can go to the other side or can stay. Mm-hmm. Can you what? That's fine. Okay. This guy doesn't have a dy dx. This guy doesn't have a dy dx. So either they both have to stay or they both have to move. Which one is it? It doesn't matter. Up to you. I'll move them. So I'm going to subtract 8x and add 8 to both sides. In the end, it will be the same. So if you chose to move the dy dx's and keep 8x minus 8, you'll get the same thing. Okay, so I got 2y dy dx plus 4 dy dx equals negative 8x plus 8. 2y and 4 aren't like terms, so we can't add them together to make 6y. So then I got to factor out a dy dx. divide by 2y plus 4, divide by 2y plus 4. dy over dx is negative 8x plus 8, 2y plus 4. That's the derivative. So look at the derivative. I have a binomial over a binomial.
Yes.
Can I reduce that?
Uh,
I have 4 terms, right? 2 on top, 2 on bottom. Can they all be divided by something?
2.
2. So you can do that. Is it necessary? No. But if this was a multiple choice question, it wouldn't say negative 8x plus 8. It would say negative 4x plus 4, y plus 2. That would be the answer. So you just got to know that they're the same. Okay, you just got to, I won't take credit off for you, but A, B, C, D, that answer won't be there. Okay, so just be careful with that. Okay, all right, so now we're getting to the actual bones of the question. What did we say? So this is the derivative, right? What did we say was true about vertical tangent lines? They have slopes that are undefined. What makes a number undefined? When we say a number is undefined, specifically what makes a number undefined?
When the bottom is 0?
When the bottom is 0. Does it matter what the top is?
No.
If the bottom is 0, if the bottom of a fraction is 0, the whole thing is undefined. Doesn't matter what's on top. So I'm only going to focus on the bottom. I could care less what the top is because I'm looking for undefined. So if undefined means the bottom is 0, I want to figure out where that is. So I'm going to set the bottom equal to 0. I'm going to set the bottom equal to 0 because that's what will determine what it's undefined or not. Solve for whatever letter's left. Solve for whatever letter's left. So we got minus 4. So when y equals negative 2, the tangent line will be vertical. How do I know that? How do I know when y equals negative 2 that the vertical line will be the vertical line will be undefined?
Is the bottom 0?
Because the bottom is 0. And if the bottom is 0,
Bottom 0, it doesn't matter what's the
bottom equals 0
It's automatically in.
means undefined
So
slope.
let's see if we can get a hole.
Okay?
You know,
So that means my point, one of my points has to have a negative 2 for y. How do I figure out what the x is?
you don't got it.
You just put X.
It says points though. So I need an x. I can't just say when y equals negative 2.
How many?
If it said when, if it just says at which points, or if it said when is this have a vertical tangent line, you could just say when y is equal to negative 2. But this question specifically said find the points. So how do I find the x when y equals negative 2? Plug in y to the original. There you go. Plug in y to the original. Plug in y to the original. So the original was 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So anywhere there's a y, I'm going to put in negative 2. And solve for x. 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. Let's see, 4x squared minus 8x plus 8 equals 0. No, 0, right? Sorry, wait. Combine like terms here. I'm trying to do it in my head, but I messed up. I got positive 4, negative 8, positive 4. They cancel each other out, so they make 0.
Yeah.
It's a binomial. So GCF, yep. I can divide them both by 4x. So I got 4x,
Well, what did it do?
x minus 2. Set those both equal to 0.
Oh, it's 0 or minus 2.
So it's going to be 2 points, right? Yeah. So divide by 4, I get when x is 0. Add 2, when x is 2. So there's 2 points. There's 0, negative 2, and there's 2, negative 2.
Yay.
At both of those, you will get a vertical tangent line. I'm telling you right now, these are this question and the next one are very, very popular free response questions. These are very, very popular free response questions.
Horizontal.
Okay.
Where can we get to horizontal?
All right. Okay, so what I want you to do is I want you to do number 9 on your own. It's almost identical. The only word they changed was instead of vertical, they made horizontal. And what do we know about horizontal tangent lines? If vertical tangent lines mean the slope is undefined, what do horizontal tangent lines mean?
0.
Slope is 0. Slope is 0. Okay? So this means and think of when is a fraction 0? When a fraction is undefined when 0 is at the bottom. But when is the fraction 0?
When the top is alive.
When 0 is on top. So get to the derivative. We only care what's on top. Okay? But you got to get to the derivative first. So we got to a point where we found the derivative, right? It's negative 2x minus y over x plus 2y. Or the opposite, right? You could have positive 2x plus y over negative x minus 2y. That would be the same answer, right? Opposite signs, all opposite signs mean it's actually the same, okay? So we know that's just the top, right? We know that all we care about for this question is the top because that is what determines if a number is 0, right? Just the top. So let's focus on that. And we want to figure out where that is 0. But this one is different because we have x and y. So you can isolate x or you can isolate y. So we're going to pick the one that's easiest. Which one would be easiest to isolate? X or y?
Y.
I think y because it's almost positive y. I don't have to divide. To isolate x, I would have to divide by negative 2. So I'm going to isolate. So I get negative y equals 2x, right? Divide by negative 1, and I find out that y equals negative 2x. So whatever y is, x is double it, change the sign. Opposite sign doubled, right? That's the relationship between them. What I'm going to do now is I'm going to use that, because when I found the derivative, didn't I plug it back into the original to get x and y? I'm going to do that. I'm going to plug in negative 2x everywhere there's a y, because that's the best I can do. Okay, that's the best I can do. I would prefer to have a number, but I don't have a straight up number. But I have a relationship. I know that y is the same thing as negative 2x. They're the same. Okay? So I'm going to do the same thing that I did. Everywhere there's a y, so I have x squared plus x times y plus y squared equals 6. Everywhere there's a y, I'm going to put a negative 2x. Negative 2x. Because I know that relationship is true. Do what I did on the last one, simplify. I get x squared. X times negative 2x is negative 2x squared minus 4x, oops, not negative, positive, 4x squared equals 6. Because negative 2 squared is 4, x squared is x. Combine like terms. Well, they're all like terms. So I'm going to get 3x squared equals 6. Solve for x. Find the square root of 2. Root 2. But anytime you take a square root, you will always have a positive version and a negative version. So we're going to have positive root 2 and negative root 2. Those are your x values. So we have a positive root 2 and a negative root 2. Last thing we're going to do is figure out what the y value is. So the last thing you're going to do is go back to the original, plug in root 2 for x, negative root 2 for x, and you're going to get two different y's. Okay? So you would go back to your original. So the original said x squared plus xy plus y squared equals 6. Oh, actually, no, sorry. Don't even have to do this. You can do that, but what's the easier way of doing it? What's the easier way of finding the y's if you have the x?
Plug in the x into the y.
We know what the relationship is, right? Whatever y is, it's just negative 2 times x, right? So we can plug it in here. I know what x is. Plug it in there, plug it in there. So we get, because we know that relationship has to be true. So y equals negative 2 times x, y equals negative 2 times x. So the first one is root 2, the second one is negative root 2. So when I plug in positive root 2, I get negative 2 root 2. When I plug in negative root 2, I get positive 2 root 2.
Yay. These suck.
Yeah.
I don't want to find the second derivative.
Okay.
Darn.
All right. What do we got? 6 minutes. We'll stop right there. We're only going to do one of them. I'm not going to make you do both of them tomorrow. First thing we do is I'm going to do one of them, and then I'll let you start on your practice, just to practice on your own. The last thing is second derivative. How do you find second derivative of implicit? There's a little bit of a change from last chapter, so I want to show you that. But okay, but yeah, we'll do that tomorrow.